Anyway, so my name is Tone Kristiansen. I work for Vianova. We're located in Norway, based in Sandvika. We're part of the Ås Jacobsen Vianova network. I'm going to talk about the management for infrastructure project called the Nordic Way. So I'm just going to remind you that you have a question. You are able to write down questions, and someone is going to collect them, and I'm going to try and answer them at the end of this presentation. So I'm going to talk about model requirements here in Norway. I'm going to show you an example project. We're going to talk about the common data environment, about data flow, and practical examples and success criteria, the way we see it from different projects. So where did it all start? We could say it started with the Norwegian Public Road Administration, who published the first BIM manual or model-based manual back in 2009. The official version came out in 2012. And we would say that it will be a driving force for constructible BIM models. This manual, it required everyone to work model-based, and it defined and described the level of details they wanted, also for the existing situation. It requires every discipline to be multidisciplinary with the quality check and collision control, and it also stated that we had to have stakeout data in the model. Back in the days, it was in DWG format. Now, after the Road Administration published this model-based handbook, Bane NOR, which is the road department, they followed closely after, describing their own, and Nye Veier, which came about in 2015, who are in charge of very large projects here in Norway, also further pushed the requirements. And what is I would say extraordinary about this is that they rank the model above drawing. It means that the drawing is secondary, but the model is required. Another thing I think it's very unique about the Norway way of doing things is the way they run their projects. They use a lot of design and build project and PPP, public-private partnerships. This requires everyone to work with an open book, be transparent about how they do things. They combine the experience of the construction and the theoretical designers, and they sit together and form how they're going to have more constructible models, resulting in good design and better roads. It also includes the clients, and the contractor ensures that the design that are done are practically possible to build and avoiding costly rework. Now what you see on the right-hand lower picture is the example project I'm going to show you. It's a public-private partnership, and it's just the way that they have organized the project. So this is the example project. It's located at the entrance of Lofoten, far up north in Norway. It's quite a large project, I think one of the biggest one in Norway at the moment. Skanska is responsible for the whole, but they have Herde, who are the subcontractor for one part. Now, the project scope, there's 7 tunnels, 72 smaller structures, multiple public transport hubs. You've got a large rest area, a couple of them. You've got overnight rest area for heavy transportation, departure parking, new intersection solutions, service underpass, collector roads, bits and pieces. The key numbers, it started, construction started in June of 2023 and supposed to be finished in December 2028. In the PPP project. The contractor is responsible for maintenance and operation 15 years after the last section of road is opened. And at most, the workforce out on site are 700 people. You got 35 kilometers going through existing corridor, 20 kilometers in new corridor, 27 kilometers of tunnel, completing the whole of 82 kilometers of road. That's how big this project is. So this is just a few images at different time of the year from the site, just to see how beautiful the scenery is as well. Now, taking on a large project like this, you see a couple of challenges and solutions that you need to align for. You need to have managing the size and the scale of the project and all the information required. You need to deliver good design solutions out on site. You need fast and effective approval process. You need a large a system that can cater for large data sets. And you need to maintain and control the climate and sustainability. So you need to align the digital requirements and ambitions as well. How are we going to work model-based? How can we measure production? What kind of tools do we need? How do we facilitate data flow the best possible way out to the people in the project, both designers and the ones that are going to be building this large thing? Now, where it all starts is that we sit down and we draw this map. It looks quite big, but it allows us to connect all the different tools. What do we need to do for issue management? How are we going to access models? What do the design need? What do the contractor out in field need? And this is what we do for every single project, that we draw this map. And you can see down on the left side, you've got the legend, like the color coding for where people access and who it caters for. And the most important part of this whole system is what you call the common data environment. Now, the design, most of them are using Quadri and connectors into Quadri. They need to have they need to develop a few drawings so the other disciplines can access. So you need a file server. Trimble Connect is in the center of the whole thing, where you deliver models. And you can view models and do the collaboration. And then you need the SharePoint for information, deliverables, and access point for other applications as well. So there's not one system that caters for everything, unfortunately, but by drawing up a map like this, you can connect all the different pieces and dots in order to run this project successfully. So in general, for the data flow is from the Quadri to the file server and vice versa. And it goes into the Trimble Connect. And then you've got the issue management via Jira. It's also connected to the Trimble Connect. So we use Trimble Connect Sync that uploads all different files from the file server every 15 minutes. We try and do as much automated processes as we can in order to get this whole ecosystem to function. We use the SharePoint for training, information, documents, and deliverables. This is where data capture from site goes into, and you've got the daily digest from the construction sites, so you can read about what's going on. You've got all the BIM documents located here, and you also got your training and onboarding facilities. And through the SharePoint, you can also access Trimble Connect and the different views and the map solutions out on field. The contractor has his own sets of tools that also needs to access the same type of data. This is just a lineup of all the different applications the contractor uses. Gemini Connected, SharePoint for documents, Trimble Connect for models. They got a few different views that connects to the different excavation equipments out on site, and Nova Render for tunnel viewing. We got the system, the CDE, the common data ecosystem, and we need to have documentation that kind of explains how we work, how do we use these systems, and how do we implement model-based design and utilize it. So in general, we create a number of BIM documents to validate how we work. You defined the BIM ambition and implementation as a document. You describe the methodology and the common approach. You state what kind of information is required and the format to be delivered in. And the disciplines have each their own attachment that describes how the different disciplines are structured and the format, and it also describes the workflow and the process. So these are the documents that we have in this example project, where you got the execution plan, the common BIM manual. Then you've got different attachments that are common to all disciplines and everyone. And then you've got the discipline attachments describing what road is going to deliver and how it's going to be delivered, what kind of information you'll find there, and what kind of survey data you will find there. Now, these BIM manuals and attachments, they are all centrally located on the SharePoint and are accessible by all parties. So you can see, well, there's a few pictures of different documents here. We can see from the SharePoint, and then we have a picture of all the different attributes and property sets that they will find in the different design models. And then you have a picture of the what we call the MMI, the Model Maturity Index, which is basically the same as level of details, which defines the different stages and the commitments done for each stage in order to be ready for being delivered out on site and being built. Now, this is an example of a disciplinary attachment where, in Norwegian, I guess some of you can read Norwegian anyway, where you can see what discipline, what this discipline is going to deliver of survey data. Now, this document here is revised a couple of times according to construction feedback, because they find that they would love to have something else delivered or in a different way. So it's being revised and then changed. So things will be more efficient and more constructible out on site. And just to give you an example of a delivered electrical model down on the right-hand corner, in the discipline attachment. They distinct between the base model, what you'll find there, and what you will find in a discipline model. Now, this project you saw, it was very, very large, 82 kilometers, and we need to think clearly about how you name all your different files. So they're broken down the whole project into different VBS, work breakdown structures. So they get a number for each sector, and then the file naming of the discipline models and the base models describe what work breakdown structure this model is part of. And then we do deliver more or less everything in the IFC format because it handles geometry and properties. We primarily use 2x3 version, and for constructions, they use a variation of 4. We do not use 4.3 yet. There are some exceptions from the IFC format. Road are delivered as road models from NovaPoint, DMR, and then tunnel is XML file for the blasting profile, and construction for typically portals, they deliver XML. So this is what the contractor wants because it's more efficient. But for road, tunnel, and construction, they still deliver IFC format for the visual and handling of properties. Now, success factors, how we see it. Like technology and information is very, very important, but most of all, it's important to have good communication and good training. Now, the contractor has its own BIM people, and the consultant also have our own BIM people. And we form a common BIM team, more or less at the start of the project. We do that to get a common arena for coordinating issues regarding information, regarding things that happens on site, what type to deliver, what do they actually need out on site. So this is an arena for us to collaborate. We have jointly meeting with the client as well every fortnight. We do the onboarding and have a dedicated place on SharePoint where all the onboarding and training facilities are accessible. We do regular webinars, which we call training breakfast. Everything in order to have an easy place for the people out on site and the people that are going to access models, to train them in how to use the tools. We do welcome all development in this project. If it's small or large, it doesn't really matter. If you find something that can make things easier, we'll try and see what we can do and if we can cater for them. Most important factor about forming a BIM team and forming this common ground is to create a climate where it's easy to talk to each other, easy to ask questions, and the BIM team is a central point of support, both the BIM team out on site and also in the office. So we dedicate a lot of focus on communication, being accessible for everyone, trying to help them out and be a support for people out on site. Now we do have 3 model viewers. They all have different strengths and cater for different tasks. We have one master viewer, which is the Trimble Connect. Trimble Connect, we have chosen it to be the project's main collaboration platform. It mirrors all design. Trimble Connect Sync is used to have all updated models out on site. Trimble Connect's got powerful functions like interdisciplinary control. It works on both PC, mobile, tablet. You can create lots of different predefined views. We've used these different views in interactive maps just to make it more easy for the people to find what they need. It's got a really good function for using the properties or attributes that you have on the IFC models via the data table. And what we regard as the success factors are the naming of files, that you have a good structure based on the work breakdown structure. For each sector or work breakdown area, you have a number that aligns with the sector it belongs to. And for each sector, you have hundreds of files. And for each sector, we create a view. It's got folder structure, which also describes the VBS structure. You can you have good access management for the different areas, who needs to see what. And for managing all the views, we use these interactive maps. We also have drone data inside Trimble Connect, so you can see the actual drone flying laser files together with the design data. And we also have a lot of symbols being used to linking information and information boards, all to cater for the people that are going to use the models to construct. We have approximately 900 users, and I hope the picture is big enough to see the marking on how many views there have been created. So in order to have an easy point of access for the people that are going to use it, we have made interactive maps of different types of views. So you have a map in the background, and you've got the different VBS zones. We have views for all models that have been delivered, for presentation models and production models. So the normally a user would open up the interactive map and then just click on the different colored dots, and the view for this area will show. Another part that the people out on the site really like is the linking of information by using symbols or information boards. So clicking on the information board will take you to a link, and you can get further information. As an example, a principle drawing of how to do this one open section ditch. I'll show you just an example of one of the boards application that the construction site uses, and it's the project footprint. We also deliver constantly information to the construction for the actual footprint of the whole project, so they can maintain and overlook the climate control. So in short, these are what we see as the success factors. By utilizing all these different tools and this CDS common data environment, we minimize the use of traditional drawings. You still need to have some drawings, but it's vastly reduced. This way of working makes sure that the contractor and everyone involved uses models as much as possible. They get fast and accurate information from these models based on the communication on what the construction needs and what we can deliver. They build right the first time because they are so involved in the process. They get a faster and better understanding of what is needed to be built. They have formed digital checklists based on the models as well, and because we have a lot of attributes in our models, the contractor have managed to streamline the ordering and purchasing process, and they create faster and better quality documentation. So that was about 4 minutes left for questions. Now, Stefan, I'm not sure really how you would like us to do the questions. Are you going to read them up for me?
Yeah, I didn't get any questions in the
Wow,
chat.
everything was just
crystal clear.
crystal clear.
I have one raised hand. I'm not sure if I can try him to allow to talk, actually. I will push the button. Jakob, you raised your hand. Are you still with us? And can you utilize some sound, perhaps?
Sorry, I don't have any questions. Maybe
okay.
It was a mistake.
Okay.
It was a mistake, so it was crystal clear then.
Have you got a question, Stefan?
I don't have any question.
No.
It was crystal clear. And for how long did you say this? When did this appear in Norway?
This big project or
the way of
requirements?
working. Yeah, the requirements.
It actually started with a common project. We'll call it a common project because it was both railway and road being built. The E6 from Minnesund, which is north of Gardermoen, north of Oslo. That's when they came up with the first initial handbook where they said that everything had to be modeled 3D. 3D models, and you need to quality check in before everything gets delivered. So that was back in 2009, and then based on the experience from that project, they formed a team of both contractors, consultants, and owners, and they created the first handbook and it was released in 2012.
So did the kind of the authorities or the the ones ordering this come out with any figures on how much more efficient projects have been done after this?
Yeah, they have. I think there's a big report that even Trimble was participating in back in 2019 or something, where they looked at all the different projects and how many arguments they had in the project and how much it actual cost. And they found that after they started using 3D models and 3D deliverables, it went down. And I also think they distinct the different types of projects on what kind of contract it was. If it was a design-build contract, or if it was a normal contract. Because the design-build contract, it involves the three parties: the owner, the contractor, and the design. That means that they can talk more together and figure out a better way and cater for better solutions. So I think that type of projects are pushing the progress.
Thank you very much, Tone. Time's up, and we will in 5 minutes start the next session. So thank you
for having me.
Thank you very much and welcome back in a few minutes.
Bye-bye.